Okay, so our next speaker unfortunately couldn't make it for the live event, but he was kind enough to record a video of his session, which we are very happy about.
Yeah.
So after this session, we will do a Q&A together with Sam Basu, who happens to be a colleague of said speaker.
Yeah.
And we have a video from Ed Charbeneau.
So let's roll it.
Hello, Blazor fans, and welcome to Writing JavaScript for C#'s Blazor. I'm Ed Charbeneau, Principal Developer Advocate at Progress Software, and I'm currently focused on Blazor. I have an ebook out there called Blazor, A Beginner's Guide. I'll give you links to download that free at the end of the presentation. You can find me on Twitter by my name. Feel free to reach out there and ask me your favorite Blazor questions. And you can always watch me on Twitch by my name again, or also on Coded Live. So first of all, let's talk about why we need JavaScript in Blazor. You know, isn't the reason that we chose to write Blazor so we don't have to write JavaScript? Well, the fact of the matter is that Blazor is really new and it doesn't have a full API surface for all of the browser's web APIs. There's quite a bit of them. This is just a simple list of those APIs. And while Blazor covers things like component model and working in the DOM and fetching things through HTTP, it doesn't cover things like our Canvas API or geolocation, web storage, our file system, those type of things. And we need to use JavaScript to access these APIs. I also want to talk about why we don't need it. So there's reasons that we don't need to reach to JavaScript as soon as we find a limitation with Blazor. That's because people have already contributed to the Blazor ecosystem, and there's packages out there that take advantage of the JavaScript Interop and do things for you so you don't have to write the JavaScript yourself. Some great examples here are local storage. The Blazor local storage package is a fantastic NuGet package that lets you write to local storage in the browser without using JavaScript yourself. Now, it uses it behind the scenes, but you don't have to write it. You write C# instead. We also have a package out there called Blazor Size to tackle runtime media queries. So you can write media queries using the component model within your Blazor application. And Telerik has a commercial component library out there that has some JavaScript interop services in it as well. One of the important things it does is lets you upload files. So you get a nice selection dialog and you can read files from disk and send those to your server. Another reason that we don't need it is there's growing support within Blazor itself. As of .NET 5 and .NET 6, we've gotten much better SEO support by giving us control over the rendering of the head tag in our applications. So what exactly is the JavaScript Interop? It's a way that Blazor can invoke JavaScript methods from within .NET, but it also allows us to call .NET methods from within JavaScript. That can get really interesting. So we're going to break down some of the ways that we can communicate with our application APIs through C# and through JavaScript. So on the C# side of things, we have a couple methods and objects that help us communicate with the JavaScript world. One of those is the .NET object reference. This is a typed reference that lets us tell JavaScript what our classes inside of our Blazor application are like. It even lets JavaScript call methods on those classes. Then we have the IJS runtime. Now, this is an instance of the current JavaScript runtime in our browser. And we have access to it by calling invoke async and invoke void async. And I'll teach you how to use this in just a moment. On the JavaScript side of things, we can capture that .NET object reference, and we can make calls back to that JavaScript object. Now, the conventions are pretty easy. We want to use a namespace on our JavaScript side of the application that extends the window namespace. So we have window, our namespace for our code that we're going to write, and then the function that we would like to execute. So for example, here we have window, myFoo is the namespace, and the doFoo is the function that we're going to call. If the function already exists on the window object, then we can call it directly, but that's a rare opportunity that we have. It's also worth noting that the parameters and values that we use with these JavaScript calls must be JSON serializable. So let's take a look at what invoke void async does. So for example, here we have a JavaScript file that has a function attached to the window called myFunction. It's going to accept some text parameter and then call the alert function in JavaScript and pass that text to it. So what we're doing here is invoking that native alert box in the browser. On the .NET side of things, we're going to inject the IJS runtime, and then we're going to call await JS invoke void async. We're not expecting a value back here. We're just calling a function on the browser. We're going to expect it to do something, but not return anything. Then we want to pass in the name of our function. Again, that function is called myFunction, and the parameter is going to be the text hello. Now, I could show an example of how this works in the browser. We'll jump out to a Telerik REPL for Blazor instance here. This is a way that you can test your Blazor code right in the browser without having to install anything on your machine. Maybe you want to just share some samples with friends or work on and troubleshoot something in your project. This is a nice browser-based way to do that. So in here, you can see I have the IJS runtime. I have some Razor code with a button that attaches to an event handler. When I click that event handler, we're going to call invoke void async, again, passing in the function name and the parameter we want to send to that JavaScript function. Now, we wouldn't normally drop a script tag directly in our Razor, but this is an in-browser experience here. We're just trying to get the job done. Normally, this would go in a separate JavaScript file, but this is, in fact, the JavaScript code that we want to call from our .NET code. So when I call invoke void async, I'm passing in the name myFunction, which gets called here off the window object. We're going to pass in the text hello, and that gets delivered to the alert method on the browser API and passed in as a parameter. So if I click on the button here, you can see at the top of the page, we've got a native pop-up with the word hello displayed in that alert box. Pretty cool. All right, back to our presentation materials. We've got some more examples to talk about and how to identify where this belongs in our component lifecycle. This is a very important part of writing JavaScript for Blazor applications. Generally, you want to avoid calling any of these JavaScript Interop functionalities from within the onInitializeAsync method. Now, I know this is where a lot of your initialization code usually goes when you're calling for data for your application, things like that. But if you're in certain instances with Blazor, especially with server-side rendering, JavaScript might not be available while the component is being initialized. So for that reason, we generally want to use our JavaScript APIs inside the onAfterRenderAsync method. So we know that the component has been initialized and JavaScript is already available. Let's also talk about lazy loading modules. This is a newer feature that came in .NET 5, and this allows us to lazy load in JavaScript code when the components are loaded into the application that need that JavaScript functionality. So it's a nice way to offload the JavaScript files so they're not all in the head of your application loaded up front when the app loads. Maybe you're not visiting those pages that need to use specific JavaScript interop code. Why load those extra resources in? Lazy load them in at the last moment. To do this, we'll use the lazy task of an i.js object reference. And then we'll use invoke async on that i.js object reference. What this basically does is sets up the code that you see below, where we're importing a module using the native API in the browser that is import and calls the module by its path. So the code you see to the right-hand panel here is the setup for lazy loading. So we're going to get a lazy task of i.js object reference called a module task. When our service is initialized, we'll pass it the i.js runtime instance. And then when the component needs to initialize that JavaScript module, it will call JS runtime, invoke async, and get a reference to the i.js object reference. It will call import and pass it the path to our JavaScript and return a task. Once we have that module, we can invoke methods on that module. And this is a nice way to make our JavaScript code portable and modular within our Blazor applications. Next thing I want to talk about is different scenarios that you may use with your applications. When we call JavaScript from our Blazor apps, there's different ways that we may need to use it depending on what that JavaScript code does. The first one we talked about already. We called a native window alert inside of our application using invoke void async. Now, invoke void async is a fire and forget. It's one way. We're going to call some code from within C# and trust that the code will be executed within JavaScript. We're not going to expect back any sort of value from that function. For example, with our alert box, the alert just prompts the user. It doesn't ask for any data back, so we're not getting any variables or arguments back from that JavaScript call. So there's no return value here. The next scenario is a round trip scenario. So we do expect to get some data back from JavaScript. So we're going to call invoke async. It is a typed method call. So it's invoke async of t, and we're going to expect back some value of that type from JavaScript after it executes that JavaScript method. And a prompt is a really good example of this. So in the first line of code here, we're setting up an expected string to come back. We call invoke async of string. We're going to call the prompt method on the JavaScript API. And then we're going to pass it, what is your name? The user will then type in some sort of value, and then the result will come back as a string inside of C#. Another round trip scenario is when we call C# from JavaScript. In this scenario, we're going to use something called the JS invocable attribute. What this does is it identifies a static method that can be invoked from JavaScript. So we add the attribute JS invocable to the first line of the code below. And we're going to expect some sort of array of integers to come back from JavaScript when this is called. And then in the JavaScript code, we're going to call .NET invoke method async. And similar to the way we call JavaScript from .NET, we're calling .NET from JavaScript. So we input the namespace and the method that we'd like to call. In this case, it is return array async. You can see the matching names in the JS invocable line above. And then we're going to push some data into an array and return it back to that method. So this gives us a way to make calls to and from JavaScript from both C# to JavaScript and JavaScript to C#. We can also do a round trip type of method call and expect a callback to happen. So this is a little bit more of an advanced scenario, and I'll give you a really solid example of this when we're done discussing what a callback looks like in our Blazor applications using the interop. So we're going to talk about invoking JavaScript from .NET, and we're going to have a callback or a promise that we're kicking off in the JavaScript side of the application, and then use a .NET object reference to call back into the C# application and execute another method. And of course, we want to make sure when we're done doing this type of a scenario that we dispose all of the resources that we're using for this type of behavior. So let's look at an example using the geolocation API in the browser. We're going to write a JavaScript interop that takes advantage of geolocation so we can get the user's current position from their device using their geolocation services on their device. So I have a class in C# called geolocation, and it's going to use invoke void async to issue a command to JavaScript to get the user's current position. Now I'm calling invoke void async, even though I expect to get a value back. The reason I'm not getting a value back to this method is that I need to wait for an event to happen on the JavaScript API to then return a callback into that C# code. And what's going to happen here is when I call get current position on my JavaScript, it is going to then get a reference back to the C# object and call the event raise on get position when the position is received on JavaScript. So we're awaiting here. We're awaiting on the JavaScript side for the geolocation API to complete. And when it does, it's going to call back into another method and raise an event on our geolocation object. And if there's an error, it will also call back into a different method to post that error back to our application. So let's take a look at an example of this in action. So I've got my project here in Visual Studio, and I've got a page here that is using the IJS runtime. It's a geolocation example, and it's going to make a call out to the geolocation API, display the position, the coordinates, latitude and longitude, also a date stamp of when that data was reported back. If there's an error, we can go ahead and display that as well. And all of the code that you see here is .NET. There is a JavaScript file in this project called geolocation.js, and this is the JavaScript side of this application that is making those calls into the geolocation service and getting back those coordinates, and then calling back into .NET and letting us know what those user coordinates are by raising the event on get position and passing in the serializable results from that API call. So if we look at this in the browser, you can see that I've got a Hello World app here. The browser has a geolocation feature enabled, and we're getting the current position, latitude and longitude back into my application, and I have a date stamp of when that happened. This is really useful if you're writing something that is talking to some service that needs to identify the user's location for maybe shipping information, or you're trying to help pre-fill some forms based on where that user is, things like that. So the geolocation APIs can be very important to your app, and this is how you would get access to them with Blazor. Let's talk about another advanced scenario. This is going to be a pub sub scenario. So publish and subscribe. This is a little bit more than what is included with the native APIs in Blazor and JavaScript for doing work with the JavaScript Interop. But you may run into an instance where this is going to be really handy, especially if you're considering an API that's going to be used with Blazor server. So what the pub sub pattern is going to do here is we're going to use it to minimize the number of event handlers that are taking place in JavaScript. So let's say, for example, we have multiple components that we're adding to our to our Blazor page or components. When we add multiple components, what we don't want to do is duplicate event listeners that may be taking place in JavaScript. What we can do is have this pub sub pattern and deduplicate some of that, so there aren't excess events taking place in JavaScript and making calls back to the C# portion of our application. Sometimes when we do this in Blazor server, we're actually making WebSocket traffic. And if we're not deduplicating some of that WebSocket traffic, we can overload the WebSockets in our application. So this might be a handy way to take care of that scenario. So we're going to deduplicate some of these event listeners. And then when things are disposed in our C# application, in our components that are being rendered, we want to remove those event listeners from the DOM so we don't continue to trigger events that aren't being accepted by our application anymore. So that's the pub sub or publish and subscribe pattern we can use with JavaScript in our Blazor apps. Now, the developer experience for this, if handled the right way, can be pretty elegant. I use this in my media query library, Blazor size. So in Blazor size, a media query list component is added to the application. That media query list component handles the setup for this publish and subscribe behavior in the library. And then when child components, media queries, are added to the application, they deduplicate their event handlers, and they also destroy their event handlers when they're removed from the application. When the user uses the APIs here, they're only interacting with components. They're not even writing any C# code. So the next scenario I want to talk about is throttling events. Again, this is very important for Blazor server. So if you can think of an example like an autocomplete box, you want the user to type in that autocomplete box, but not trigger an event on every keystroke. Instead, you want to wait for the user to pause or finish typing before you kick off that event. So throttling or debouncing those events might be useful, where we're going to wait a certain number of seconds for the user to stop the activity or for so many events to take place before we actually make a call to JavaScript and then update our application. So an example of this I use in Blazor size for detecting the users when they resize their browser. I don't want to trigger an event as the user scrolls the browser's window size. I want them to stop moving the browser window size before I trigger an event. So to do that, we call clear timeout. This is a JavaScript method. And then we also call window set timeout. And we tell the JavaScript API that we want to clear any events that happen within this window until the final timeout is hit. Once the activity has stopped, the JavaScript code will execute and report back to the C# application, letting us know the event took place. That way we don't have thousands of events accidentally taking place over 300 milliseconds. Instead, it's going to wait every 300 milliseconds to report back to the Java or the C# application. I also want to make note of testing and tooling. With all of this type of development, you can use NPM. I would suggest using it to bring in your packages. These things are very friendly with .NET these days. For testing, you can use something like Jest. It's a great JavaScript testing library. TypeScript is wonderfully compatible with all of this as well. And you can even use other tools like Rollup.js to compile or bundle your JavaScript into deliverable. TypeScript supports the .NET object reference. The type here is going to be a number or a string, depending on if you use Blazor server or client-side Blazor with WebAssembly. So with WebAssembly, you're going to get an integer, and with Blazor server, the .NET object reference will be a GUID. So keep in mind, those are two types that may be interchangeable here when you're writing your TypeScript. It's also important to remove any JSON files from your NuGet packages. This can throw erroneous errors when people are trying to build applications that are consuming your package. And then there is built-in support here for your namespace and folder in which your JavaScript will be deployed with your component library. So you're going to build a Razor class library, and your assets will go in the www root folder of that class library. When you need to reference this JavaScript file, it will be under the namespace, under the content folder, then the namespace, and then the JavaScript file that is in the www root of that Razor class library. So www root becomes _content / namespace, then your JS file. And it's important to provide minimized and standardized formats for this. You can provide alternatives as well, but it's best practice to try to minimize these files for your end users if you're going to ship them as class libraries. So you can find resources for this on my website at charbeneau.com. There's a link there to my free ebook with examples. There's examples on my GitHub page as well. The link is off the main page of my website. Feel free to reach me on Twitter or watch me on Twitch. And you can find more information about Blazor at blogs.telerik.com. Thank you all for attending. It's been a wonderful conference that everybody has put together here. Fantastic speakers throughout the day. Hope you enjoyed it.
That was so nice that we could actually get Ed without getting Ed.
Yeah. And now we have Sam.
And we have Sam.
I'm live.
Hey, Sam.
Yes. Hey. Hello, hello.
So Sam is our stand-in Q&A answerer. Is that a thing?
That must be a word. That must be a word.
You should put that on your resume.
Yeah, maybe. And I'm just lurking here, ahead of my scheduled time. But I'm actually good friends with Ed Charbeneau. He's had a family emergency this week, and we all know family comes first. But it was nice of him to at least record his talk. And yes, I'm here. I think Jimmy may be much more of a Blazor expert than I am, but I tinker. Let's dive into any Q&A, and maybe Jimmy and me could also maybe talk about our thoughts about calling JavaScript from C# and vice versa.
Yeah,
that sounds good.
So maybe Daniel or Jessica, maybe if you feel free to pull up any questions. But Jimmy, what do you feel about the whole JS interop thing?
Oh, don't open that can of worms.
Well, without the interrupts, Blazor wouldn't really be possible to do, since there are some things that, as Ed mentioned, there are some APIs that we can't call using Blazor. So being able to access those things with these interrupts are amazing, I would say.
And I also think that is the answer to this comment. So.
Yeah.
I was going to save this for, later on in my talk. This is .NET front-end day. You're supposed to talk .NET all day, but I think Ed and me are the black sheep. We will talk a little bit JavaScript, but maybe just show you how to mix and match the two. And I agree, Jimmy. So without the JavaScript Interop, and I posted a link to the docs on Twitch, you won't be able to do a lot of those things. But a couple of things that Ed mentioned at the start are really key. Like the timing of things is important. You might be running Blazor server side, and in that case, the rendering matters as to when you get things done. And also, this may be key. So when Blazor is running either server side or fully client side with WebAssembly, it actually maintains an internal representation of what's called the DOM, which is the document object model. That's our visual tree in HTML. I think any elements that Blazor is trying to render or work with, you may be best not manipulating or touching them through JavaScript, because then you are changing things that are different from Blazor's internal representation, and then you are messing with like the time-space continuum, and bad things will happen.
That's absolutely true. I was actually in a discussion on Reddit a couple of days ago where I said, well, that Blazor basically removes everything I hate about web development. So JavaScript, well, that is obviously not true, but a little bit of JavaScript. Same thing with NPM. I'm not using that daily now as I did before. And as Ed mentioned, it still works with NPM. But I got backlash straight away saying that, hey, Blazor is not done, there's not enough components, so NPM is definitely still a thing working with that in that way. But as you mentioned, doing things with a DOM can mess things up. So it's really important to be careful and test things. Ask me how I know.
No, and it's important. Like nothing is here to replace or change. These are all technologies we have at our disposal as developers to do the right thing for our web apps. And Blazor and JavaScript can perfectly happily exist side by side. Throughout the day we can talk about a lot more things. You have me and James and Dan. We are all going to talk about Blazor outside of just the web itself. Like now it's very welcome on mobile and desktop. So that opens up newer avenues, right? It's not just the web APIs that you're trying to invoke through JavaScript. Now you have access to all of the .NET APIs if you are running things natively on mobile and desktop. That changes the dynamics of how Blazor works, not just on the web, but also on mobile and desktop form factors.
We have a comment here. Web dev has gone downhill since we stopped using tables for layouts.
Well, I haven't stopped using tables. I still use my tables in HTML.
We have a reply to that one as well. Disagree, we peaked at Flexbox, and since then it's downhill.
And you like Flexbox.
I love Flexbox. When Flexbox walked into my life, everything was unicorns.
Yeah, it is nice. Especially some of the layout systems, like you see, stuff that we have done for desktop for the longest time. Now we are, rediscovering the same problems like routing and layouts, everything for the web, and things are being done right with, CSS layouts or Flexbox. But to the point of front end development, especially with JavaScript, is so complicated. Right? It is just layers of stacks within the front end itself. Your build processing system, your preprocessors, your front end, a couple of different frameworks that you're using, everything is opinionated. So I'm not jealous of folks who live and breathe in that world every day.
I think it's good that you can use what you're good at, your current skills, and just bring your own flavor to it.
Yeah. It's always the right tool for the right job.
Yeah. We just did a massive new backend at work, and I'm convinced that if we didn't move to Blazor, that project would never have been done in time.
Yeah. But you were all C# developers,
exactly.
So you had that for free.
Absolutely, for us with the team, the knowledge we had, Blazor was the perfect fit.
Yeah.
Yeah, and again, to your point, Chatroom was talking about what Stacy was doing. There are lots of options. If you want to do JavaScript, you are happy to do progressive web apps or Electron or all of these other options. It's whether you want to do .NET or or not. I think that's key, right? Blazor and .NET MAUI, these things will let you write C# just about everywhere.
Yeah.
Now, if you have existing investments in JavaScript, enterprises can't just like throw it away. You have to maybe have it coexist if you now want to start doing more C#. And to your point, Jimmy, like a lot of .NET shops have kind of done .NET in the back end in the last couple of years, right? Because you had to do a modern front end and you had to choose JavaScript. Now you have Blazor, yes, but what do you do with your Angular or your React app? That's that's a new investment for the last 5 years or 10 years. So again, it comes down to like, what do you want to do moving forward? How do you want to modernize? And it's a good thing that .NET and JavaScript can kind of live side by side.
Yeah.
We have a few questions from the chat here.
Yeah.
So how do you measure telemetry with Blazor, especially post log4j? Is there an official NuGet package for Azure App Insights?
There is a package that you can use with Azure App Insights. It works just as the normal package. There's no special package for Blazor, at least not that I've seen.
So are there any difference between Blazor Server and Blazor WebAssembly, for example? I mean, Blazor Server is probably
right.
just
So
any .NET app.
that is a good that's a good point. My answer was for Blazor Server because that's where I do most of my work. Blazor WebAssembly, I don't know. Do you know, Sam?
Well, it depends a little bit on what exactly you're trying to measure. If it's time spent on UI, people clicking around, that kind of stuff you can do from any UI automation type tool or NuGet packages that give you that kind of insight. But if you're trying to measure like what kind of packages you're sending back and forth, then that's wildly different between server side and Blazor. So client side. But I think the App Insights tool is meant to work for both. I actually haven't used it for client side, but it is, like you said, it's one NuGet package that works for both.
Yeah. Okay, next question. If we host Blazor inside another app, MAUI for example, can the hosting app make use of the interop or just the contained Blazor app?
That's a great question, Joseph Foreman. Jimmy, I can try taking this, and you add your thoughts. So the moment you put Blazor inside of a shell, and keep in mind, Blazor you can wrap it inside of a progressive web app shell, run it on desktop, nothing stopping you. You can put it inside an Electron, nothing stopping you. And again, off late, as you'll see throughout the day, we're going to put Blazor inside .NET MAUI, right? So when you do that, there are some interesting choices in terms of how you get to the APIs and what exactly does your interop look like. The good news is if you are using .NET MAUI, right? So both MAUI and Blazor run on the same runtime. That's .NET 6, right? So you don't have to use any interop. You can, in fact, invoke .NET native APIs on Windows, on Mac, on iOS or Android, straight up from Blazor, which I'll actually love to show some of this during my session. But if you are, considering bringing in some other type of JavaScript, like let's say you bring in Angular or jQuery or React into Electron, into .NET MAUI, then that opens up, the need for you to do JS Interop, right? Because otherwise, .NET and JavaScript cannot talk to each other. JS Interop is the way, and it's not fun code to write. It's a little clunky because you have to really be aware of the syntax and like what Ed was saying, like what exactly am I passing in, what am I supposed to get back from a promise, and everything needs to be serialized so that we are not messing with the bridge in between .NET and JavaScript. But for Blazor in particular, bringing it inside of native apps. If it's MAUI, then you don't need an interop. And this is kind of what we'll talk about throughout the day. The story is really nice because you can invoke all types of .NET APIs straight up from Blazor.
Right.
Nice. So we have reached the end of the session. But there's 2 more questions, and maybe you could take it to the chat room with those.
Sure.
Would that be?
Yeah.
Awesome. So thank you so much, Sam, and we will see you soon for your session.
I'll go eat a quick lunch and come back and join you.